Hello everyone. So today we are going to work on a way to determine this player character by this line trace. So if I go into the view of the line trace, now the line trace is following the beam is following the player character, and if I break the line of sight, it continues to do the sweeping as before. So that's what we are going to work on today, detecting enemies from the turret. Let me show you again. Now I am detected again, so that's why he is following me. Break the line of sight, he do the usual sweeping. Alright, so let's see how to do that today. So here we will again use some C++ interfaces to detect enemy characters and some more stuff. And this episode is sponsored by these generous patrons. Thank you very much for your support. Okay, so last time we added the C++ based character to our system, and now what I want to do is, if from this laser beam, if the character is detected, it should detect the character as an enemy, and it should keep following the character instead of doing this sweeping around behavior that we have at the moment. So first let me go to this oh wait, what happened here? This is scaled up for some reason. So this is the scale it should have. Let me copy that and paste. Right, so let me remove collisions for this laser beam because we don't need that. And right now the character can just simply walk through that. Cool. So to implement detecting the character as an enemy from the turret, so what my plan is to use an interface here when we do this line trace from the hit result. If we can access the actor which hit the line trace, so like this hit result dot actor get actor utility to return the actor that owns the component that was hit. Right, so okay, and then we need to check if that actor is an enemy character. So for that, let me add an interface Unreal interface. I'll call it character interface. Create class. Okay, compilation complete. Took a while and I have to reload the project. Alright, so this is the character interface CPP, which we don't need to do any modifications, and this is character interface.h. This is what we need to do modifications. So here I'm going to add a function called, so this should be a u function, and at the moment I don't have a requirement to call this from blueprints, but maybe in future I might need to, so I'll make it blueprint callable. And if I mark this as a blueprint native event, I will be able to implement this function in blueprints. And let's define a category as character. Right, the function is, it should return boolean IsEnemy. Okay, so now let's implement this character interface.h in our third person C++ class tp third person character. So tp third person character is here. So we can implement the character interface, but first we have to include the header file of the character interface. Dash include so to include the character interface, we have to use these two dots. The reason is the third person character is inside this tp third person folder and the character interface is in the above folder. So to navigate to that, we have to use these two dots. Now I can access character interface, but I think there is a way to, instead of using these two dots, there is a way to add that to path and make it work as well. Let's use this way for now. Right, now here I'll implement public character right. Now we have to implement this IsEnemy function, but when we implement it in C++, we have to use this. We have to do it this way. Let me show you. Pool IsEnemy underscore implementation override. So this is the way to override an interface within C++ defined in the interface. Right, let's create the definition of the function. Okay, so this should simply return true because our character is an enemy. So yeah, okay, let's compile and see if we get any errors. Right, compilation complete without any errors. And now let's go back here. So that's all we have to do in the character class. And the next thing is, in the turret, we can use that function and check if we hit an enemy with this line trace. So instead of doing that part here, let's add a function, function void check and so here we should give a hit result. No, actually we can pass a reference of the actor. Reference to actor. And here we are not going to do any changes to this past pointer, so we can mark this as a const function. Okay, now let's implement this. Right, now here, so we get the reference to hit actor. So here, how do we call this? Check enemy, and we need to get hit result get actor. It returns the actor that owns the component that was hit. Right, now here we can check if hit actor implements 𝐿_character interface. Oh wait, I have to include the header file. Let's include base.h. IntelliSense is still running, so I don't I got the autocomplete. So if this is true, we can call the IsEnemy function to determine if this particular actor is an enemy or not. So yeah, bool enemy equals character interface execute IsEnemy. I don't get the solution. Oh, this should be equal. Execute IsEnemy. Object is hit actor. Okay, and if the enemy is true, that means we have detected an enemy. So let's add another variable to the turret. I'll add it as u property. At the moment I don't have a requirement to access it from blueprint, so I won't add any property specifiers. Actor pointer enemy. Right, now I'll set enemy as this hit actor. Okay, also I'll add a UE log temp. Let's add it as a warning so that I can easily see that. Text is enemy detected. Oh, I think because of this const I can't modify this value. Let me remove the const part then. compile. Right, compilation complete. Let me pull this down a bit so that it can easily hit the player. Did I get the enemy detected part? Where can I open the output log? Right, enemy detected is showing up here. What is this? Failed to create an initialize. Well, regarding this one, this is not relevant to what we are doing here. But project settings, I did some searching, UDP messaging. Transport, unmarked enable transport. That's what suggested here. Right, I don't get that anymore. Okay, now let's try again. See if we get the player warning, detected warning. Yeah, we got it. See, okay, enemy detected. Right, the next thing now what I want to do is when the enemy is detected, the laser beam should follow the enemy. So to do that, let's add another function in the CPP turret function called follow enemy. Right, function implemented. Let's go to the function. Right, so here what we want to do is we need to calculate the rotation from the turret to the enemy, and we have to update use that rotation instead of the rotation update we normally do, which is here. One more thing, I think we should give delta time. We should pass this as a parameter. We would need that when we set the rotation. Okay, so first we need to calculate the rotation from the turret to the character. So we can copy this part actually. The starting point is this beam socket and end point is enemy get at the location. And then rotator enemy, not enemy, rotation to enemy. We can calculate it using mathf. Sorry, not mathf. Fmath find log sorry, this is not implemented in Fmath, it is in your 𝐂𝐚𝐧𝐧𝐞 library. Find log at rotation, starting point is start and end point is end. then we can update look rotation. Actually we can copy this part too. Here, look rotation. So instead of this part, I can set the look rotation like this. Let's do math. Printer to look at rotation. So we are interpolating the current look at rotation to this rotation to enemy. Rotation, we need to give delta time. We have that as a parameter, and interpolation speed. Let's try 1 and see what happens. Okay, and since I have duplicated this part here and here, I think we should promote this part to a separate function, but let's see if the code is working first. Right, compilation complete. Let's play. Oh wait, actually I didn't call this follow enemy function anywhere yet. So in the tick here we can check if we have an enemy. If we have an enemy, we can call follow enemy. Else we can call this update look at target. Time. Compile again. Compilation complete. Right. It seems it is following the character, but feels like too slow. So what we can do is we can increase this speed. Let me try 10. Actually we can define a parameter for this, an editable parameter, so we can change it in the editor, but let's not complicate this. See, now it's following pretty fast. Alright, so now our turret can detect the player and follow the player. So what if we go behind an object? Still it follows the player. So here if I increase the interpolation speed, I think the turret will be able to constantly identify the character without missing it. See, now it always identifies the character. So if character is not detected, we can remove the character reference pointer, and so the turret will follow the usual pattern. So here, if this is false in the check enemy, that means character whatever the actor not that hit by the line trace is not implemented in this function. Else enemy equals null. One thing I forgot. To avoid any unexpected behavior, I'll initialize this with the null pointer. Right, compilation done. Let's see. Okay, now this is following the character. Let's try breaking the line of sight. See, now it's doing the usual thing. Let me go into the view again. Now I'm detected again. Let's break. Okay, now it's sweeping again. Alright. Cool. So I'm gonna stop this episode right here. In the next time I'm going to work on actually shooting from the turret to the character. And thanks for watching. As always, project files will be available here in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.